welcome to this episode of Night Sky News for January 2021 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about everything that you should look out for in the night sky in the coming month, and we chat about what's been happening in space news in the past month. So without any further ado, let's kick things off and start by looking up. Right, so there's so much to see in the night sky at the minute, especially in the Northern Hemisphere with these long winter nights we've got. There's ample opportunity to look out for things, at least if the weather is kind to us anyway. But if you've never stargazed before, if you've never looked at the night sky before, it can be a little bit overwhelming. You're not sure what you're actually looking at or looking for. So I've got a couple of tips for you, just to be able to spot things a little bit more easily using something that's very easy to find, which is the moon.
Beautiful, isn't it? The moon.
So on January 22nd and January 23rd, there's going to be a half moon which will be very close to the star cluster Pleiades. It's going to be high in the sky towards the south from sunset to the wee hours of the morning. And Pleiades is a fantastic sight even with the naked eye. It looks sort of like 6 to 8 stars all clustered together in the shape of sort of like a little mini plow or mini Big Dipper, whatever you call it. But if you have telescopes or binoculars and you can look at it through that, then it'll look even more spectacular. More stars will appear as well in this tiny place on the sky where they've all formed very close together. I got some new binoculars for Christmas as well, and I'm so excited to properly try them out, especially on Pleiades. We've had so many nights of cloud through the end of December and beginning of January. I'm starting to get a little bit frustrated. I've not even had a chance to test them out with my tripod yet. These are the Meade Astro 15 by 70s. So they're going to give me such a spectacular sight, and you know that I'll be breaking them out for Pleiades this weekend. Then as the month goes on, the moon's going to be moving across the background stars into the middle of what's known as the winter hexagon or the winter circle. It's 6 of the brightest stars in the winter sky that essentially ring the constellation of Orion. If you start at Orion's belt and move down to Orion's foot, that's Rigel. Then you go across to Sirius, the dog star, up to Procyon, up to Pollux, to Capella right at the top, back down to the reddish star Aldebaran, and finally joining back up to Rigel again. And it's known as the winter hexagon just because it's so obvious in the winter sky. It's visible from right after sunset all the way through till around about midnight when it sets, depending on, where you are on the Earth, what your latitude is. And once you've spotted it near Orion, you can't help but see it again every time you look in that direction. So if you want to add it to your stargazing repertoire, then on January 25th, which is a Monday, it's Burns night as well, head outside, find the moon, and then just go from there and see if you can spot it. Then by the time February 10th comes around, the moon will no longer be a half moon, but it will be in its crescent or toenail moon phase, as I like to call it, and visible in the east just before sunrise. And on February 10th, it will be joined by the wonderful sight of Jupiter, Venus, and Saturn all in a row on the sky for half an hour or so before sunrise. Venus is the one in the middle, and it will be the brightest, about 6 times brighter than Jupiter, which is the next brightest, and then Saturn. Now, these are going to be quite low on the horizon, so you need a really clear view eastwards to be able to see this. So if you can't usually see the sun actually peak above the horizon for the sunrise, you're probably not going to be able to see this. So those of you on eastern coasts or in apartment blocks with windows facing east perhaps that are quite high up, or perhaps just isolated on a hill in the countryside, you guys are going to have the best chance. Plus all of you that are further south as well. The further south you are and the closer you are to the Tropic of Capricorn, they're going to look higher in the sky before sunrise. Whereas here in the UK, they're probably not going to get high enough above the horizon before the sun rises for us actually to be able to see this, which means we're probably also going to miss the conjunction of Jupiter and Venus here in the UK as well, which is happening a day later on the 11th, again, just before sunrise in the east. Now, conjunction is when 2 planets look very close together on the sky, i.e. they're not actually close together in real life in the solar system, but from Earth's perspective, they look close together. Now, Jupiter and Venus are going to get within about 0.4 degrees of each other on February 11th. So if you hold your thumb out in front of you, that's about half a degree. So that's about the distance they're going to be separated by. It's about the distance of a full moon on the sky. So not as close together as Jupiter and Saturn came in the great conjunction we just had in December, but still pretty close together. Again, those of you at more southerly latitudes are going to have a better view of this because they're going to be higher in the sky before the sun rises, whereas those of us at more northerly latitudes are probably going to struggle. We're probably only going to be able to pick out Venus against the sort of brightening background sky from the sunrise. Jupiter's probably just going to be a bit washed out, to be honest. But wherever you are in the world, if you do manage to catch this or any of the things I've talked about this month, then please send me your pictures on social media. I always want to see them, and I'll share a few of my favorites. All right, that's enough for looking up. Let's come back down to Earth with a bump, and let's chat about what's been happening in space news in the past month. All right, let's kick things off with some good news about the Arecibo telescope in Puerto Rico. Remember last month there was the really bad news that it had collapsed due to structural damage? Well, in late December, the Puerto Rican governor Wanda Vázquez Garced allocated $8 million to rebuild the telescope, stating that the collapse presented an opportunity to redesign the 60-year-old radio telescope in order to make it relevant and useful to the scientific community for decades to come. I, for one, am thrilled at this news because, the Arecibo telescope was an absolute legend in astronomy and astrophysics, so to see it get written off after the collapse was just really, really heartbreaking. So, I'm excited for what's to come, to see it get rebuilt. I'm excited for sort of the liaison that's going to happen sort of in the astronomical community to say, well, what do we need now? What do we think we're going to need in the future as well in terms of a new telescope? So I'm excited to see where that will lead. And I know that, no rebuilding is going to happen anytime soon. It's going to be a long, drawn-out process, but I am really looking forward to the day when I can say that I am working with new data from the Arecibo telescope again. All right, so I had loads of stories that I wanted to talk about this week, but as usual, not enough time. So if you want to hear about JAXA's plans to put up a wooden satellite into space, or you want to hear about the rumors of the strange radio signal that's coming from Proxima Centauri, the sun's closest star, then head over to my YouTube stories and my Instagram stories to check those out. They'll be going up at some point this weekend, but I'll also save them to a highlight on my Instagram profile, so any of you, watching in the future won't miss out either. I've also saved a story on some research that's come out with evidence against dark matter and for MOND, one of these modified theories of gravity. But I'm planning to give that a whole video of its own to do it justice, to explain it fully about why it's so exciting and what they've found. So look out for that coming out next Thursday on my channel. But for now, let's talk about the fact that we now have a new most distant galaxy ever found in GN-Z11. It's at a redshift of around about 11, as the name suggests, actually 10.957 plus a bit of measurement error, which means the universe was only 450 million years old when that light was emitted from that galaxy and started on its journey to us. That's only about 3% of the universe's current age, around about 13.8 billion years old. So it means that the galaxy was at a distance of about 13.4 billion light years when the light was emitted, but of course the universe has expanded since then, meaning that the galaxy is now 32 billion light years away. Now, for a couple of years now, people have suspected that this might be the most distant galaxy ever detected because it was spotted dropping out of Hubble Space Telescope images. Now, that happens for a couple of reasons because of what happens to light on its way to us from distant galaxies. So the first thing that happens to light is that it gets redshifted by the expansion of the universe. Essentially, the wavelength of the light is stretched, and more stretched waves are redder colours. So everything gets stretched to redder colours, even down into the very long infrared wavelengths. The second thing that happens to light is that it passes through clouds of hydrogen gas that just happen to be on its path from the distant galaxy to us. When that happens, the hydrogen gas actually absorbs a little bit of that light, and it always absorbs the exact same colour or wavelength. And the combination of those two things means that, the light passes through one cloud of hydrogen gas and loses the little bit of light at that specific colour. It then gets redshifted some more until it passes through another bit of hydrogen gas, another cloud of hydrogen gas, and then it loses some more light from light that wasn't absorbed before because it wasn't the right wavelength, but has since been redshifted to the right wavelength. and therefore gets absorbed. And the combination of both of those things overall means that anything with a shorter wavelength, so bluer of that specific color that's absorbed by that hydrogen gas, essentially gets completely lost on the journey from the distant galaxy to us. So picking out where that complete drop-off of light actually happens allows you to work out the redshift to that very distant galaxy and therefore work out how far away it is. But the thing is, there's actually a limit to the most distant thing the Hubble Space Telescope can pick out, because that drop-off eventually gets redshifted and redshifted and redshifted some more until it's actually beyond the limit that the Hubble Space Telescope can detect. It's been redshifted so far that it's gone way into the infrared and beyond the limits of the infrared light that the Hubble Space Telescope is actually sensitive to. So this is why people are so excited for the launch of the James Webb Space Telescope later this year, fingers crossed anyway, which is sensitive to longer wavelengths down into the infrared. So this is why you hear astronomers saying that the James Webb Space Telescope will actually be able to see further, because it will be able to detect the only light that's actually left from these distant galaxies that hasn't been absorbed by hydrogen on its way to us. So this galaxy GN-Z11, it had been known for a while that the redshift was around about redshift 11, but we didn't know that very precisely because of the way that we pick out these distant galaxies from the data taken by the Hubble Space Telescope. So ideally what you would do is you would take a spectrum of a galaxy where you take the light and you split it through a prism, and then you can make a nice graph of how much light at every single wavelength you're receiving, and then you see that drop off very clearly. Hubble doesn't do that. Instead, what Hubble does is it takes lots of different images of the galaxy through filters that only let through a specific range in wavelengths. And so at a certain range of wavelengths, you don't see anything. And then all of a sudden at the redder range of wavelengths, you do see something. And you can tell that drop off occurs in a specific range, but not precisely where it is actually happening. But a study this month led by Jiang and collaborators did actually take a spectra using the Keck telescopes on the summit of Mauna Kea in Hawaii. And this allowed them to measure the redshift so much more precisely at, 10.957 plus or minus a little bit of measurement error still, and confirmed, what people had long suspected, that GN-Z11 was the most distant galaxy from Earth that we have ever observed. All right, sticking with galaxies, but coming a little bit closer to home, I want to talk about this galaxy that's been spotted, that's burping out 46% of its entire supply of gas at a rate of 10,000 suns worth per year. This has been found by Puglisi and collaborators in a galaxy which has been classed as a starburst. That's a galaxy that's recently formed a truckload of stars in a relatively short amount of time. Now you can imagine 100,000 years or so down the line, you've got all of these massive hot stars running out of fuel and therefore dying and going supernova in pretty quick succession. And that can cause this huge drive outwards of a lot of material from the galaxy, essentially removing a lot of the gas that you need to make new stars. And that's a process that we call quenching, i.e. we quench the stars from forming. We stop stars from forming in a galaxy by some process, either by removing the gas or heating up the gas or preventing that gas being used in some way. This is actually what I do as part of my research, but I look at how black holes, like growing black holes, could actually cause this. I've done a video on how you kill a galaxy before, if you want to check that out, and I'll link it up here. Now, at first, Puglisi and collaborators thought that this big outflow of gas that they detected, just with a slight different redshift to the stars in the galaxy, so they knew that it was moving at a different speed and outflowing from the galaxy. They thought it was caused by all of these supernovae going off at once. But they also found evidence that galaxy is recovering after a big merger with another galaxy. You can sort of see this in the radio images, that it's still disturbed. And so what they ended up concluding was that it was that merger of two galaxies in the past that have, left behind this remnant galaxy that we see today, that triggered both the starburst, where the galaxy formed a truckload of stars all at once, and also this flinging out of gas from the galaxy, not by a load of supernova going off at once, but through the gravitational interactions that tore apart those two galaxies as they merged together and ended up flinging out nearly half of all the galaxy's gas out into intergalactic space. All right, one last thing for all of you who are still with me. Who remembers my beloved Planet 9, this purely hypothetical planet thought to be orbiting the sun way beyond the orbit of Pluto, the existence of which has been suggested to explain the shepherding of some of the orbits of the asteroids and dwarf planets way out on the edge of the solar system. Now, it's a purely hypothetical planet because we haven't actually detected yet, but if it did exist, it would very nicely explain some of the weird things that we see out on the edge of the solar system. So people estimate that, it's probably around about 5 to 10 times the mass of Earth, and at the distance it is, it would probably take about 400 to 800 years to finish an orbit around the sun, so it's really far out, and there's loads of ideas for how it could have got there, from, being a planet that formed very close into the sun and then being flung out, to, being a rogue planet that was wandering interstellar space and then got captured by the sun's gravity. Some people even suggest that the reason that we haven't spotted it yet is because it's actually a tiny black hole the size of a tennis ball, and that's my personal favorite theory. But now we've found a Planet 9-like thing in another star system, making the idea that the solar system has a Planet 9-like thing that bit more likely. Now, this work was done by Huen, De Rosa, and Callas using Hubble Space Telescope images of the star HD 106906 over 14 years to try and spot any planets that were orbiting around it in that time. So they found a planet around about 11 times the mass of Jupiter, orbiting at a distance 737 times the distance from the Earth to the Sun from its star. Now, at that mass, at 11 times the mass of Jupiter, you're very close to the limit at which you go from being a planet to being a star at 13 times the mass of Jupiter. That's the limit at when you can start nuclear fusion in the core, and therefore you start producing your energy and you become classed as a star. So around about 11 masses of Jupiter, you're not quite in that grey area of planemos, which I've done a video on before, where, is it a failed star or is it just a really heavy planet? But the authors of this paper do state that it is planetary mass sized. So there's a lot of similarities between the suspected properties of the hypothetical Planet 9 in the solar system and this newly discovered planet HD 106906b. But it's the differences that have got people excited, because the star that this newly discovered planet is orbiting around is very different to the sun. First of all, it's a binary star, but also it's much, much younger than the sun. It's like an astronomical spring chicken in comparison, at only about 50 million years old. Compare that with the sun's 4.5 billion years old, and you'll see what I mean. So the fact that something like this has already formed or been captured, if it was a rogue planet, roaming interstellar space, in such a short space of time of only 50 million years is really interesting. So by studying this system further, it'll help us nail down our ideas of how an object like this might have formed in the solar system at some point, and maybe, just maybe, help us finally find the elusive Planet 9. And finally, a quick shout out to the live stream I'm organising and hosting for Oxford Physics next Thursday, the 28th of January from 3 p.m. until 9 p.m. UK time. I've convinced all of my colleagues to give talks about their research and to take part in some Q&A panels as well, so get thinking of all of your good space questions. Plus, we've got kid-friendly activities from 3 until 6 p.m. for everyone homeschooling at the moment as well. The link is in the description, and I'll see you there. Before we get to the bloopers, I just want to thank this week's video sponsor, Brilliant. Brilliant is a website or an app that makes learning interactive, accessible, and most importantly, fun. They are all about visualizing concepts, really seeing them and interacting with that content so that you're much more likely to actually remember what you've learned. So if you want to learn more about how we detect planets around other stars in the Milky Way through transits, or how they make their stars wobble, then check out the sections of their fantastic astronomy course, which covers all the basics in such an engaging way. Honestly, these courses are so good. So if that sounds like something that you want to start doing this year and you want to support me and my channel, then head to brilliant.org/Dr. Becky. That's DRBECKY, and sign up completely for free. Plus, the first 200 people that go to that link will get 20% off an annual premium subscription, so you can just learn anything that your heart desires. So thank you so much to Brilliant for that. And now, roll those bloopers. First up, on the 22nd and 23rd of January, the moon is going to be very close to the star cluster the star custard. Yummy. It's a really nice sort of comforting sight to be able to spot every winter. So if you want to sort of add that to your stargazing repertoire, the Puerto Rican governor Wanda Vázquez Garced, where is my phone? It's there. Found it. Infrared. So this is why you'll hear astronomers say that the James Webb telescope can't find planet 9 rarer than the glimmer of a comet in the sky. 'Cause it could be a black hole. Long story short, we couldn't find.